All right, Devin, you said you want a little bit of a tutorial on how to use that pedigree and figure out probability. So here we go. We're going to use an example of cystic fibrosis. So that is a recessive trait. So you have to have two parents who are carriers in order to have a child with it. So we're going to pretend that we have a male and a female who are looking at having children. Okay, so they are going to have kids. Now, each one of their parents, they did not have cystic fibrosis. However, we'll call him, I don't know, Bob. Okay, here's Bob, and here is Joe. Okay, so Bob does not have any recent family members who has fibrosis. However, Bob's great uncle had cystic fibrosis. Okay, so he had CF. That's why I wrote that CF there, is to indicate that he had cystic fibrosis. So, what we can tell about Bob's, about Bob's great grandparents is that they were both carriers for cystic fibrosis. So, if they're both carriers for cystic fibrosis, that is how their child could have possibly gotten CF. Okay, so you have great grandma, you have great grandpa, and so just using our knowledge of Punnett squares, we can reorganize that. And so here is his great uncle who would have passed away a long time ago, but that's not his grandfather. Okay, his grandfather did not have cystic fibrosis, so that means that he had to be either the homozygous dominant or the heterozygous form. So that means that his grandfather here had to be either one of those two. So he was either homozygous dominant or heterozygous. So we have to figure out what are the chances of that occurring. So there are three options. So out of the four boxes, three of them do not have cystic fibrosis. However, two out of the three are carriers. So what we're saying is the probability that Bob's grandfather is a carrier is 2 out of 3. Okay, so if we have that information, we can assume that Bob's grandmother on his dad's side is not a carrier. So if that's true, then we can create a new Punnett square. Okay, so I'm going to get rid of this one. And so now we have a different combination of parents. Both parents are not carriers. So we have one who is a carrier, and we have one that is homozygous dominant. So our probability changes. Now there is a 50-50 chance of Bob's father being a carrier. Okay? So now that Bob's father has a 50-50 chance of being a carrier, this same Punnett square can be used for Bob. So if Bob's father is a carrier and Bob's mother is not a carrier, then that means that Bob has a 50-50 chance of being a carrier as well. Which is important because if Bob and Jill are going to have a child who has cystic fibrosis, then they both need to be carriers. So we're trying to determine what level of probability they have. You know, is it absolutely they're going to have a child with cystic fibrosis, which we know is not possible because even if they're both carriers, there's only a 1 in 4 chance. But we're just trying to figure out what is that probability. So for Jill, it's a little bit different family situation. So Jill's mom has a sister. So Jill's aunt also has cystic fibrosis. Okay? So it's kind of the same idea. Jill's grandfather would have been heterozygous, and Jill's grandmother would have been heterozygous, meaning that there is a 2 out of 3 chance, the same as Bob's great uncle, that Jill's mom is a carrier, because out of the 4 possible Punnett squares, or the 4 possible squares within the Punnett square, then 2 of them are carriers. One of them is actually having the disease. Her mom didn't have the disease, so that means that there are only 3 possible boxes left, so that's the 2 out of 3. No, I'm just reiterating that, but I want to make sure that you understand that connection. Okay, so same thing. We can go back to this Punnett square over here, because this is going to indicate Jill the same way that we are assuming that Jill's father is not a carrier, and Jill's mom could be a carrier. There's a 2 out of 3 chance that she is a carrier. So that comes back to using the same Punnett square, where it is a 50-50 chance. So if Bob and Jill are going to have a child, even if they are both carriers, then their child has a 1 in 4 chance of having cystic fibrosis if they're both carriers. So that's why I use the analogy of, if you have a coin and you flip it, the chance of getting heads is 50-50. But that's not really how we figure out probability. The chance of getting heads 2 times in a row is 1 in 4. Because it's 1/2 times 1/2. To get it 3 times in a row, it's 1 in 8. There's a 1 in 8 chance, because it's 1/2 times 1/2 times 1/2. So we're going to do the same thing, where we take the figures that we have on this probability, and we're just going to multiply them. So I'm going to take 2/3, so 0.667, I'm just converting that into a percentage, times 0.5 times 0.5 times 0.25 for their possible child, times 0.5 times 0.667, and what we get is Jill and Bob have a 1.4% chance of having a child with cystic fibrosis. Okay, so Devin, I hope that helps you out. If you have questions, send me an email, or yeah, let me know. We can talk about it when you get back from break. Okay? Good luck, and like I said, if you do have questions, let me know.